Everybody, let's have a look how to use this plugin. And here, first thing are all the links that I use here in the video. Also see them in the description. First thing, I installed Neo4j in a container. In my case, I used the Bitnami version. You can use also the latest Neo4j standard version. Important is it's running. You can access it. You know the password. In Bitnami, it's Neo4j and Bitnami1 as password, or Neo4j in the standard version. Then I can use here match and return n, so I match all the nodes and return them, nothing there, so we start with an empty database. First thing now, using Tortoise, I clone the directory here under developer.bastian BA Neo4j and have it fully cloned to my local disk. That's one of the things I will later show how to use it with a new project from the marketplace, or just copying here the directory that we need into a new project. So we have cloned it here. You see the content. Let's open it from here. If you use it, all the plugins will already be loaded. We use two of the Unreal plugins. Let's have a look at them. One of them is this HttpRequest plugin. That is here. It's experimental, quite early. And the second one is the Json blueprint utilities. That's better with the newest release, so kind of stable. And yeah, now you see this directory here, BA Neo4j. We have a maps directory. If you open the maps, that is a couple of actors that will on overlap do certain things like creating nodes, connecting to a database, deleting nodes, and kind of showcasing what you could do and how to do it. First things is this data table for connections. There are 3 connections predefined, one with no authentication, one with Neo4j authentication, and the third one with the Bitnami authentication, that is Neo4j and Bitnami1 as password. All need to be encoded with this Base64 encoding. That is something that is in C++, is actually available in Blueprint. It's extremely hard to rebuild, so we just use an external website, base64encode.org, and here we just state the username and the password, and you get this encoded string. That is not encrypted. It's clear text, so you can always kind of go back to your username and password with it very easily. So be sure that nobody gets that, and all the information stays on the server and all the communication is on the server, never on the client. So that's the first thing. We have one of the connection being true, active connection being true. That is what will be looked at. And first thing, we have to install the actor component, Neo4j actor component. That is installed here. You see successfully installed component on this third person character. Second thing, we test the database, we connect to the database and see, yeah, it's a Neo4j kernel 5.13. Then we create a couple of nodes. So these are 5 example nodes that are coming from my inventory. So match and return and shows, yeah, 5 nodes. 3 are connected to one central node and 1 is, yeah, on the side. The central node is the items base node, and from that item base node you will see certain things like currencies and weapons and so on and so on. The data are coming from the examples here, data tables base nodes. It's always the same information. You have a row name, you have a name of the nodes, you have a GUID, you have a couple of labels in an array, you have a root GUID if you have a connection to a root, and you have properties, a string map that can be as long as you need. Looking at that, that's exactly what you see here. So you have one base node with a GUID. You have a couple of properties, a type equals node here, for example. It has a name, and it might have some root information if it's connected to something. So the child is always referring to the parent root. Or not, then it's a single child. Now we do the same, but with a lot of more information. That is the periodic system elements that I use. So that is here. These are 99 elements all connected to one single element space node. And yeah, here we created more than 100 objects. So 99 nodes, 99 relationships within a very short time, so it's quite fast. And that is the basis for it. That's the data table for the periodic system elements. Down below you see the Google Sheet, how to do it, how to create it from the Google Sheet into JSON objects that can be important in such a table. I might do a video about that later if you're interested. And your data are here in the properties. So you can add string tables that can be as long as you need for all the information you have here. Get all nodes, gets a dump of all nodes, and deleting them means the database should be empty, and it is. So all of these overlap events are doing certain things. We will look later how. Second thing is, if I don't want to clone the project but start with an empty project, or you have an existing one, let's create a project that is now an empty third person template. And here we just have to get this directory in, and we have to make sure that the plugins are installed. So HTTP Blueprint is not installed as a standard. Same goes for the JSON Blueprint utilities, also not installed as a standard. So you have to add them, restart, and now we can add this directory. Either now we do it directly, just copying, pasting it, or you do it from the marketplace and select your project. It will happen, or will do the very same. So copy it here from our clone project, go into our demo content, and just add it here. The Epic project browser will do the very same. If you say from the marketplace, add to my project, it just copies these files really. Here you see this this directory, this folder with the same information. Let's open the map again. And here we go. Same thing, starting with an actor install, testing the connection, creating these 5 base nodes, creating 99 element nodes, showing all nodes, deleting all nodes. That's quite fast. So what is actually happening in all of these actors? Let's look at the Neo4j actor component first. First thing it does on start is initialize connection. So it actually looks if there is anything to initialize. What is the connection to the database? That looks at this data table connections, looks for the first active connection. The first, everything else is ignored because it breaks after it. And then a couple of meta information from that connection, like the name, the URL, and this Base64 encoded string are stored in the actor component itself. And that will be used and reused all the time if you build up a connection to build the header, mostly. So I have stored that. So the second thing is this send query. We only have one send query here that is used and reused for everything. It takes a header, it takes an URL, it takes a query, a text string, then it processes the response that is again a text, and reacts with a dispatcher. Look at this URL here down here. I have a video really going into the detail what exactly happens here. Now it's just a short overview how to use it. The event dispatcher is always the same in our case. It makes much more sense, of course, that you have an event dispatcher per query or per situation, let's say. Otherwise, you reuse it again and again, and then you will run into overlap at one point. Processing response, meaning creating this huge string into a JSON object. Same thing, I have a video here that looks a bit deeper into it. At the end of the day, you have this JSON response, and you really have to convert that into something that is much easier to use. So mostly converting this string into a couple of Unreal or an array of Unreal objects. These are these response objects that are easy to read and easy to handle. That is what happens here. This GraphDB response is, let's say, the encapsulating object. That is not much more than showing all the arrows and having an array of response objects, and each response object is equal to one response from the database, meaning one node or one relation, for example. And here you have all the information in either the rows or the meta string maps. And these you could use, for example, initializing another Unreal object that you have in your game. The request objects kind of does the same. We have to take the request information, put them into certain things like label arrays, parameter maps, or GeoIDs for your route. And that is then used to generate the other way around a text object that can be sent to the API. The examples that we have here, looking at the base nodes, that is exactly what you need. You have a couple of information like an array of labels or a map of properties, and that is then converted to a JSON object, and that JSON object is then sent to the API in a certain format. Let's look a bit deeper into it, how that works. We go to this create base node, where these 5 nodes are created. First thing, we make sure we only act on authority. We look for a Neo4j component of the overlapping actor, if that exists. If not, we report an error. Then from that component, we will bind this event dispatcher. That is what we use in the moment that something happens. If something happens, we process this response. We will get a response object, and we directly unbind from it because we want to reuse it with different routines. And what we do here is not much, it's just really printing out that text. Now we go to really creating our request. In our case, we load the data table for the base nodes, and we iterate over this data table for every row. We know we want to create nodes. So we have this request here, base node add base node. We break the struct and reuse a couple of information. For creating a node, you need kind of things like a label and the and the properties and stuff like that. Looking here at the struct. So GUID you need, label, the name, the properties. What you don't need for the node itself is things like relation and root GUID. That is something you need for creating a relation, not a node. So we leave that away from the moment. Then we set the request, that is add base node, and we add this request object. If we know it is connected to something, so the root GUID is not empty, or is not valid, or is valid, then we only use the relations and the root GUID. And here we added the node, but here in the second step, we have to add the relationship that we need. Let's look here at this enum. The enum that we use is clear text, simply because it's a bit tricky. If you give the Cypher queries to the end user, you would not know exactly what it does. So we use this enum to make it kind of readable, and then later we have to match it to a couple of Cypher queries. So here you have the Cypher queries. Yeah, I linked here a manual to get started. It's actually quite easy, it's much easier than SQL. So these queries will be matched to the, let's say, human readable text, but will be used in the background. And here you see we have things like parameters that we have to set. We have a couple of information that we will replace, like labels or relations or props. And that is what we use as a base, merge it with the request object and replace whatever strings we need here, and have to make sure that we have a valid JSON object at the end. So here we added the node. Second thing, we want to match it with Cypher query. We have the Cypher queries map here. On the left, we have an enum, and on the right, we have one entry of the string table, one of the Cypher queries. And if you add a new one, you would extend the enum and you would add it here as a mapping so that it's known what kind of Cypher query will be used. Other than that, yeah, we have the things like process response, this one here. Then we have the build header information that takes the information we stored from the data table, like URL and connection name and so on. And very important, write or read. Then we have this initialized connection that we saw, looking at the data table for an active connection. We have this build query information that takes the existing request objects and make it a valid Cypher query. So first thing it does, it takes the mapping from this enum to the Cypher query. It takes then the string of the Cypher query. Here we have it here. It takes the string of the Cypher query and does a lot of really replacement. If it has no parameters, it's easy. Then you can just fire it like match and return n or call database components. That is an easy one, but normally you will have a lot of parameters in your queries. Parameters can be really API parameters with this $, or kind of text replacements. I normally take it with uppercase and $. When you after you created all these request objects, you send a query that is a bit more cosmetic, and then last step, you send that query, you envelop it in a kind of statement, JSON, and then you send it to the API. Other than that, we have a couple of macros for reporting and for doing this string replacement. We have this event dispatcher. That's the important thing that we will call when we have a response and when we have converted the string response into a response object. That is exactly what the routines, the calling routines, will receive afterwards. Good, let's have another look. We have here. So we will get this response object at this point. So this event will be fired. We process on our side this response object, we unbind, and then we do something like, for example, printing out text. Here would be your game journal logic. Let's run again. You see it's quite fast. For example, the periodic system generates 200 objects within less than 100 of a second. So I hope that helps. If you have questions, there's a Discord and a mail. Thank you.